And now we come to formants. Formants are the concept that tend to trip people up the most. So don't worry if you don't get this right away. I know it took me a while to really understand this. So please feel free to watch this video as many times as you need. But here's what you need to know about formants. Let's look at the definition. A formant is an acoustic resonance in the vocal tract measured as a peak in the frequency spectrum. Now, when you looked at Voce Vista and we saw all those harmonics, some of those harmonics actually were louder than others. So in the acoustic resonance of the vocal tract, there's peaks in the frequency spectrum. There are these frequencies, these harmonics, some of them have peaks. And where we see a peak, we call that a formant. Basically, all acoustic spaces boost certain frequencies, depending on the size and shape of the acoustic space. If I have a bottle of water and I blow across the top, I'll get a pitch. If I drink some of that water, that pitch will lower because I've increased the acoustic space. If I add water and blow across the top, the pitch gets higher because now the acoustic space is smaller. A boosted harmonic means a formant value equal or close to the harmonic. Basically, where we see these boosted harmonics, where we see harmonics getting louder in the acoustic space, there's a formant there. Now, formant isn't a thing. It's basically a measurement of the acoustic space. It tells us how the acoustic space is going to affect the sound wave and all the multiple harmonics coming in. It's very much like the EQ system. When we change formants, it's like changing that EQ system. We can adjust our acoustic space to move the formants around, to move the value of the acoustic space around, to give boosts to different harmonics. Now, looking at this in Voce Vista, we can see this second harmonic is standing taller than the other harmonics, which means it's louder. That's how it's measured in Voce Vista, which means that there is a formant there at or close to the value of this harmonic, so that the acoustic space has been configured in such a way that this harmonic here is the one that's going to get the boost. And that's how we know that there's a formant there. A formant is a way for us to measure the acoustic space. It tells us what the acoustic space is going to do. Now, we can't see the formant until we put sound into it and then see how the sound reacts. And where we see those peaks, we know that the acoustic space is configured such that it's boosting those. We know that there's a formant there. A large space will boost lower frequencies. Well, that makes sense. A tube is bigger than a piccolo. If I lower my larynx, I'm going to get a darker, lower sound. If I raise my larynx, I get a higher sound because I have changed the acoustic space. If a large space boosts lower frequencies, a smaller space boosts higher frequencies. Makes sense. Just like adding or subtracting the water, the smaller acoustic space will boost different frequencies. A larger space equals lower formant. It's a lower formant in the large space. What's going to be boosted in the large space are going to be lower frequencies. We will see that spike, that peak on lower harmonics. We will see spikes or peaks on higher harmonics in a smaller space. A smaller space equals a higher formant. And you'll see we can adjust the space. And as I said on higher pitches, the harmonics are further apart. So we can adjust the formant where it falls in between the harmonics. And that's not what we want, because now our acoustic space isn't really boosting any of the information. We need to adjust the formant either higher or lower to align it with the correct harmonic. When it falls in between harmonics, we lose energy and we get various vocal problems from that, mostly instability. we have two main resonators in the voice. We have the throat that we talked about, and we talked about how there's a power boost in the mouth. There is possibly some leakage into the nasal cavities, although they've tried to measure how much resonance is in the nasal cavities during proper singing, and they're not really finding anything, which is actually somewhat counterintuitive because as we sing higher, it almost feels like it's going up behind the soft palate into the nasal passages. Again, what we feel isn't necessarily what's happening. Vowels change the size of the resonators. This is extremely important. It's very obvious the difference in the mouth between ah and oo. I have to move my lips, round them and move them closer together for the oo, and I have to spread them apart for the ah. If I say ah and e, you may not be as aware of this, but the tongue moves forward on the e, ah, e. And the back of the tongue is an acoustic separator. Again, an important concept. The tongue moving back or forwards is going to change the size of the throat and mouth in terms of being an acoustic space. Now, the one aspect that we really often miss is what happens at the throat. You are going to have different positions of the larynx for different vowels. As I'm talking, if I put my finger on my Adam's apple, I can feel it bouncing up and down because certain vowel sounds require a smaller acoustic space provided by the higher larynx, and other vowel sounds require a bigger acoustic space or lower formant, and that is caused by the larynx dropping. If I say ah, I feel my larynx in one position. If I say it's in another. It actually needs to drop for the So I really can't make an ah sound on a low larynx, and I can't make a proper sound on a high larynx. As you change the vowel, you're changing the value of the formants. Each resonator has a formant. The throat provides a formant, and the mouth provides a formant. And actually, these two boosts combine together to give us the vowels. But as you're changing your vowels, you're in direct control of the size of these acoustic spaces. You are therefore in control of the formants, and you're in control of aligning the formants to a harmonic. Right here, you can see what the tongue does on different vowels, and the position of the tongue is going to change the size of these resonators. So here we have an ah sound. The tongue is down and flat. But here on the e, the back of the tongue, and you can feel it as you say e, the tongue will come forward and touch the top teeth. The back of the tongue has moved to here. What has happened is that here is the divider of the acoustic spaces. So we have the throat that is this size, and we have the mouth that is this size. Now with the tongue forward, the mouth resonator has become quite small, which has raised that formant. But the throat resonator, there's a much greater distance from the vocal cords to the back of the tongue. So this resonator has become bigger and it has lowered its formant. Vowels contain two formants. That's why we have vowels and other instruments don't, because we are able to combine two boosts in resonance. We take two resonators and we put them together, and the ear hears this combined boost of resonance as a vowel. The first formant is supplied by the throat. The second formant is supplied by the mouth. F1 is the lower formant. F1 is the way they write the first formant. So when you're looking at the literature, if you see F1, you know that they're talking about the first formant or the throat resonator. F2 is the higher. F2 is provided by the mouth. Now what I mean by higher and lower, the first formant, the throat resonator, acts as a bass amplifier. It's really good at boosting lower frequencies. The mouth resonator is more like a treble amplifier, and it's really good at boosting higher frequencies. Where we get into trouble is trying to get the main power boost from the wrong resonator. When we try and hit a high note but we're trying to primarily boost it with the first formant or the throat resonator, it begins to jam up. The larynx has to rise in order to follow the pitch, and people often talk about it feels like I'm singing from my throat. That's because they're caught up in the wrong resonator. So going back to this diagram, we can see here now on the ah going to the E, what's happening to the formants. E has a higher second formant and a lower first formant. Whereas oo, the tongue comes back, so oo has a lower second formant and a higher first formant. You see what's happening there? The back of the tongue is an acoustic separator. It's actually it acts like a little wall there. It doesn't really look like it, but it really does function that way. So the position of the tongue is going to dictate the size of these resonators. And as the tongue moves, the size changes and we get different formant values. To recap, the voice produces complex sound waves comprised of multiple harmonics. And we see that in Voce Vista. You see all those peaks that are coming in, all of those frequencies, all of those notes, if you will. It's like the chords are emanating a very complex chord. The resonators provide formants which boost certain harmonics. It's like our EQ system. We can boost certain harmonics. We can boost certain parts of the sound spectrum. So the sound wave comes into the throat. That formant aligns with a harmonic, gives a boost to it. The sound waves continue into the mouth. That will pick up a higher harmonic and give a boost to that. And those two boosts come together and form what we recognize as different vowels. Now, this is why singing low is easy. Vowels or formant harmonic alignment is easy in speech because harmonics are close together. Remember, we talked about how harmonics are multiples of the fundamental. So if the fundamental value is low, like that A110, then the harmonics are only 110 cycles apart. So it's pretty easy for the formants to hit something. But when we're up on an A440, well, now they're 440 hertz apart. Much greater distance, 4 times the distance. So it's easier for the harmonics to fall away from the formants. The formants don't align. They actually fall in between the harmonics, and we don't get the proper boosts, and we get all kinds of trouble. Vowel alignment is difficult on higher pitches because harmonics are increasingly spread apart. That really is so much of the difficulty of high notes. Sure, the chords have to make the adjustment for pitch, but so much of the problem is because we are not able to properly align a formant with a harmonic. We need those alignments to create those power boosts, not just to amplify the voice, but it actually creates energy that stabilizes the whole instrument. As harmonics move further apart, the formants must realign. If you have a vowel that works on a low note, that's great. You have that alignment of the first and the second formant have aligned correctly, and they're each boosting a harmonic. But up on a higher note, the shade of that vowel very likely no longer lines up with a harmonic. And again, you've fallen in between them. So what we must do, and you've probably heard this before, is vowel modification. That is, we have to take the vowel and change the shade of it slightly in order to regain alignment. That's why singers spend a lot of time learning how to pronounce words in different parts of the register. That's why we do this. It's all about the formant-harmonic relationship. In the next video, I want to build on this and get into some advanced concepts, specifically where bridges are, what's occurring there, and what you need to do in order to get helpful formant harmonic alignments and avoid the unhelpful ones.